Okay, so this video has a lot of stuff to help you to make some small life decisions, but it's also good for your exam. So stick to the end. So I basically have this rust problem here. This is one of the worst ones. Hope there's no structural damage there. And you'll find that hopefully I'm going to just spend $200 to fix this rather than get them all replaced at about $1,000 a window. That'll cost me like $10,000. So you can save yourself a lot of money by looking at the chemistry of it, which is also going to help you with your Y12 exams as well, because it covers a lot of that stuff as well. So first of all, just on a theme here, I think I'm working harder than you guys are. It is the break before the exam, so all over in a month, end of October, and you've got 3 months holiday after that. So I sure hope you're not taking this 2-week mid-semester to break as an actual holiday. I can tell that there's not enough people looking at these test questions. That's only done yesterday, but this was done a month ago and there's only 6 views, and someone who's actually doing these questions might actually be watching it 6 times, pausing and replaying it. So I can't guarantee that's actually 6 real people. And as I've said before, these are the questions that the people get wrong on the exams, these ones on the website. So they are the ones you need to do above doing everything, including going to study camp, or whether it's Griffith or your school's camp over this 2-week period, or even doing past exam papers. You need to focus on the exam prep questions as number one priority. Okay, so moving on, this is why I haven't got to this job, because I've been doing too much work on prepping you guys for your exams. But I do need to do something else besides school prep during these holidays, which is fix this rust problem. Now, rust basically only has 2 real ways of solving it. You can either divert the reaction, where's my pen, or put a coating on it. So sacrificial protection is the preferred method. So if it's something expensive like a ship or something, they'll put zinc on there, and that will react. You can see we're going in this direction here. So these will be positive. So you can see that the zinc will react and get oxidized before the iron does. And what they do is they just replace the zinc. All right. So certainly in submarines, so billion-dollar submarines, they're not going to rust. They're not going to risk losing it. They're just going to replace the zinc every now and then, so that the hull, the iron, doesn't rust. And so that is not a practical solution, because the zinc, you're not going to put zinc. It's expensive, basically, and they're heavy metals and stuff. So you don't want zinc lying around the place, even though your body does need micro amounts of zinc. Interesting enough is coating it. One way to coat it is actually coating with aluminium. That's plus 168, but it is actually way more reactive. So nothing in chemistry is that simple. The fact is aluminium is highly reactive, but as soon as it forms this aluminium oxide layer, it's impervious to water and none of the other aluminium reacts. And so ironically, it is way more reactive, but unreactive at the same time because of that. Whereas with rust, it actually forms, it doesn't form a solid coating and breaks apart. So water can still react with the fresh iron underneath. And so most applications are blocking that some way, either putting a layer of paint on there or a layer of oil, or more expensively coating it with zinc or aluminium. Okay, so moving on, that sacrificial protection is not really there. It's really about coating it. So before I move on, I was looking for a book for my other child. This is my number one here, my favorite child. But for my other child, I was looking at a book, and they had the same number of pages, same words, and it was $5 more expensive in a bookshop. If you go online, it's almost double the price. There's no difference between these books, except for this one has the word Disney on it, I think. And I don't even know if it's a better looking cover, but it's just the cover. It's a newer cover, so you're paying double the price. for the exact same book. I wonder if you just ripped the cover off, it would probably only be worth $5. So that's a lot of what's going on here with these chemicals. If you take a careful look at them, God knows if that's really fish oil. When they say fish oil, I'm thinking snake oil. Snake oil solves all illnesses. It's just a con. And it says it's all about getting into the crevices if you read the instructions. So I think, that's all they tell you. All right, and it's combustible. So it is actually just an oil. So you're just covering it with oil, but for some reason you're paying $46 a litre for it. So God knows what's going on there. I wouldn't do that. I would just spray it with some canola kitchen oil or anything, or maybe something a bit more professional like WD-40 or something. Wouldn't pay that price. I think that's just a cover you're paying for, a pretty book cover. So what's actually going on is most of them are acids. And so if I go back to your PowerPoints for Unit 2, I've undenied it. I've never completely deleted this bit here. So acid plus base gives salt and water. Acid plus metal oxide gives salt and water as well. And so that's what we've got here. They're acids creating some sort reacting with the iron oxide so it can then be removed. So what I'm thinking here is, well, doesn't the acid also going to react with the metal, and even more so? Where is it? Here, acid plus metal. And I think how they get away with this one is you can see the massive bulging and increasing surface area. And so, first of all, they're not using strong acids, they're using weak acids. And so the reaction is slow, and the surface area is so much greater here. So the metal oxide actually does this reaction first before the acid can actually react with the good metal that you don't want it to react with. And so that's how they get away with it. Also, it's at the surface. So theoretically, you're removing the top surface layer, and then once you're done, it'll start reacting with the iron, but not much, because you were just doing it for a short time to remove the iron oxide. So I think that's how they get away with that. And as you can see, the products are just acids that react with the metal oxides in this first acid equation before you get to the unwanted reaction of the second acid equation. And so what we've got here, I just looked at some products. What shocked me was the price of these things. So, you can't buy like just 2 litres or something. So you're going to have to fork out $85. And this is what I said before, just a weak acid. And it forms beneficial phosphates of iron. So that's all the clues, and it's got an acid thing here as well, corrosive. So that's all the clues that this is just phosphoric acid plus iron oxide gives iron phosphate plus water. What you should see here is it looks a little bit like a carboxylic acid. So the oxygen pulls the electrons here, and so that makes this strength quite weak. So with an alcohol, the hydrogen won't come off because it is quite strongly bonded. But when you put this extra oxygen on here, it takes away electrons, doesn't make it as negative. The hydrogen comes off much easier and then becomes a weak acid. And so all of these 3 hydrogens come off. Not only that, all this negative is quite attractive to a positive ion. This one will be 3 plus. And it binds to these quite nicely as well. So that all works in its favor of reacting and removing that iron oxide. Other products are just as expensive. This one's $33, and it's got the same deal. Carboxylic acid is a weak acid. This will be negative, this will be negative. It'll bind the Fe3 quite nicely. And even on both sides, there'll be another molecule, so it sort of wraps it up quite nicely. And it's a little bit dangerous. So I suggest not buying the Disney cover and just going to, it used to be $1 a bottle, but now it is like almost $2. That's inflation for you. And it's the same thing. It's the same deal. It's a weak acid. And so just use vinegar. It's good for the environment and it's good for your pocket. So if you want to see, how much it costs to get delivered, there's some petrol price. And if you think Coles Woolworths has a monopoly and is jumping up prices like 70% from $1 to $1.70, look what happens when Chemist Warehouse or Bunnings have real monopolies you'll triple the price. So these anti-competition laws need to go to Bunnings and Chemist Warehouse because their prices are, you think you've seen inflation. All right, what about $3 a bottle instead of $1? So as I said before, hell of a lot cheaper than paying $85. So I think I'll be using ethanoic acid to clean. But is the cleaning really necessary? Dulux is a bit more of a reputable brand. It's been around a long time, and they're dealing with paint. So they're saying you just skip the step altogether. And so clean. This is all the treat side of things. Cleaning I'll definitely do. I'll remove as much as I can with, as they recommend, sandpaper and stuff. But the treating, I will actually do it with some ethanoic acid just to get rid of that little bit extra. But they say you can just literally just prime it straight away. All right, so they're just basically layering it with another paint, basically a polymer. So they're putting a plasticish layer on the top, and that'll also bind to the paint. Okay, so I will still do it, but not for the hundreds of dollars that's going to cost me, maybe for a couple of dollars instead. All right, and we'll see how that goes. So as I said before, I'll need a stitching time saves 9, so hopefully there'll be a part 2 to this video. Will take me a while to do the first one, especially I'll do the worst one first. All right, and I'll take some pictures. There might be a part 2 to this blog. So grab all that and realize you need your Year 12 chem, not for your exams, but just for general life afterwards. All right, see you then.